What are allotropes? Sketch the structure of two allotropes of carbon, namely diamond and graphite. What is the impact of structure on physical properties of two allotropes? What exactly are allotropes? If a given element can exist in more than one states, what is the meaning of more than one states? Same chemical composition, but if it can exist in more than one forms where the chemical properties are different. Even the physical properties are different. Allotropes have different physical and chemical properties, but they have the same chemical composition. If this is possible for a substance, then the phenomenon is called allotropy. A very common error is sometimes people say chemical properties are same. No, chemical properties are definitely not same. Ozone is an allotrope of oxygen and they have very, very different chemical properties. Diamond is an allotrope of graphite and both of them have absolutely different chemical properties as well. Diamond has a tetrahedral structure, polymeric tetrahedral cross-linked structure. Each carbon is joined to 4 other carbon atoms. Each carbon is joined to 4 other carbon atoms and it goes on repeating like this. Graphite has hexagons, hexagonal rings, just as the rings are present in benzene, and these are fused rings. And they go on infinitely repeating, and each layer is linked to the other layer and the other layer. There are layers stacked one above the other, and these layers are attracted to each other by very loose van der Waals forces, and these layers can slip over each other. So, can we compare their properties? Yes. What is the impact of structure on physical properties of two allotropes? That's very easy. I'll just write down few physical properties which you can compare with great ease. First of all, density. Which is more dense, diamond or graphite? Graphite has layers which are kept one over the other and they are not attracted much to each other. There is significant gap in between these two layers. Same number of atoms will occupy larger volumes because of these gaps. Volume is more, the density would be less. So you have diamond has a greater density than graphite because graphite has significant gap in between the layers of graphene or the flat planar layers. A second very important factor is hardness. Hardness is something which is very, very popular. Diamond is much, much harder than graphite. Graphite is soft, you can make it powdery. Actually, it is used as a lubricant. On the other hand, diamond is so hard, it is the best possible abrasive. You can use it for cutting, polishing the hardest of the other substances, and it works very well. Third is electrical conductivity. Diamond is an absolute insulator. It has no loose electrons. It does not conduct electricity. Diamond is much, much less than, I'll use a different color so that I'm visible, and thick pen also I'm going to use. Diamond is much, much less than graphite. This is more, this is more. Oh yes, this is ugly and visible. Yes, indeed. What about thermal conductivity? That also is a very interesting property. And you find that thermal conductivity, thermal conductivity of diamond is more than graphite. Why? Very interestingly, graphite does not, graphite is a thermal insulator. Surprisingly, diamond is an excellent conductor of heat. So diamond can conduct heat but not electricity. Graphite can conduct electricity but not heat. These are very interesting 4 points of comparison between their physical properties which can be related to their structures.